cutting-edge biomanufacturing aboard the International Space Station. Presented by Science at NASA. Most likely, you're aware of 3D printing, which allows you to design and produce one-of-a-kind pieces for a variety of purposes. But what if you could use that same technology to manufacture biological materials, like new tissue or blood vessels? Welcome to the world of 3D biomanufacturing, a cutting-edge practice on Earth that is being tested aboard the International Space Station, or ISS. Dr. Mike Roberts, Deputy Chief Scientist at the ISS U.S. National Laboratory, explains why the space station is critical to biomanufacturing's future. We've been able to grow cells in a lab for well over a century, but gravity limits that growth to 2 dimensions. Cells can grow outward, but not up and down like they do in the human body. Also, lab cells are often in contact with the glass or plastic that contains them. But aboard the space station, our experiments will be conducted in microgravity. That allows you to build your cell models in 3 dimensions, without being confined to the bottom of a dish, or unable to grow in contact with lots of other cells. Biomanufacturing imagines the ability to someday grow a viable human organ. Organs are composed of specific tissue intersected by blood vessels. Most organs and thicker tissues in the body have a rich, complex network of blood vessels that provide nutrients and remove wastes from the living cells that make up the tissue. We currently lack the ability and the tools to engineer these highly branched, living networks of vessels inside layers of tissues on Earth. Another medical advantage to manufacturing biological parts in space is the potential to bypass the body's immune system. Today, organ transplants from donors are prone to rejection because the patient's body perceives the new organ as a foreign object, and their immune system tries to attack it. But with the ability to grow tissue in space, a person could conceivably have their own cells used to make their new organ, which might avoid the body's rejection. 3 different types of biomanufacturing facilities will be tested aboard the space station. 2 of them perform in a manner similar to a standard 3D printer. They extrude cells in layers to build tissue. The 3rd type uses powerful magnets to position the cells in place. Each of these 3 different approaches to bioprinting in microgravity will be available to medical researchers seeking to better understand how to engineer tissues and organs for use in repairing injury and curing disease on Earth. As Dr. Roberts notes, the 3D bioprinters represent cutting-edge technologies that could clearly benefit health outcomes on Earth. I think the ability to manufacture a fully functioning human organ will take some time, maybe a decade or more, but the knowledge we'll acquire to get there will also create interim benefits as we learn more about cell regeneration in space and its application to humans on Earth. For more inside information about studies inside the station, visit www.nasa.gov/ISS-science. For more on science happening on, around, and beyond our planet, go to science.nasa.gov.